Hello, this is question 9 on your AQA A-level maths paper from November 2021. So it's paper 1. You have a table that shows the annual global production of plastics, P, measured in millions of tons per year for 6 selected years. Yeah? So these are the years, these are the millions of tons of plastics produced. This is a question that appears in an A-level paper, but it's a question that you should be able to do after the first year because you don't see logarithms and exponentials again in the second year. It's thought that P can be modeled this way, where T is the number of years after 1980, which is the first year, and A and K are constants. So that the graph of log to the base 10 of P against T should be linear. And we have to do using algebra, so we cannot use the graph. What we can do is to take logs because we need to prove that log against T is a line. Yeah, so we are going to take logs in both sides to the base 10. So this is in one side, and the other side I have this. And I'm going to use the properties of the logs to separate and to organize this a bit until it looks like a line. So if I use properties of the logs, I have a product, so I can write the sum of the logs. And then here I have a power, so I can write it at the front. So this is going to be log to the base 10, P log to the base 10, A, plus KT log 10 to the base 10. I know this is 1, so the last thing I can do is write this. Log to the base 10 P is log to the base 10 A plus KT. And I think that this is a variable because sometimes when you have so many letters, it's difficult to remember which one are the variables. So this is a variable and this is a variable. And I have to prove that log P against T is a line. So log P is like acting as my Y in my line. This is going to be, this is a number because A is a constant. So this is going to be like my Y-intercept. And then I have K, which is a constant, that will be my gradient, times T, which is like my X. Yeah, so if you compare these two expressions, this would be a line, yeah, where K is the gradient and log A is my Y-intercept. Yeah, this is the first part. Then we have to complete the table below, but it's just finding the log in base to the base 10 of these two numbers here. So for 15 and 25 years, is this one and this one. So I have to do log of 156 and log of 260, which is just using the calculator. They are all rounded to 2 decimal places, so I'm going to do the same. And the first one is 2.19, second one is 2.41. Yeah, that's 1 mark, so nothing else. Then we have to plot log P against T. So we have to represent these points in that graph. So I'm trying to do it more or less quickly. So 188. So you see there are 5, 10, 20 squares in 1 unit. So that means that every little square is 0.05. Yeah, so this is 1.5, 1.75, so 1.8 will be somewhere here, something like that. 5197, so 5197 will be here. Put that one. Next one is 10208. 10208. Somewhere here. No. Here. Next one is 15219. 15219. 2231. Somewhere here. And the last one is 25.2.41. 25.2.41. So something like here. And now we do a line of best fit. It doesn't need to be perfect. It could be slightly different for everyone. Yeah, roughly something like that. Then hence, so that k is roughly 0.02. So k is the gradient. So we can use the line of best fit and calculate the gradient of the line that we just represented, or use the points because we have the values here. Yeah, so we can find the gradient, and I would use always the first point and the last point. So the gradient of this line would be the difference in y, so 2.41 minus 188. So the gradient is 2.41. Sorry, the gradient, that is k, yeah? Remember when we compare the expression with the equation of a line, k is the gradient, yeah? That's why I'm finding the gradient. 2.41 minus, first point is 188. 188 divided by the change in x, and the change in x I think is 25. No? It's 25 minus 0, so 25. And this is 0.0212, which is roughly 0.02. Yeah. You could use the line of best fit that you draw. You will get a slightly different number, but still you will get the marks. Yeah. So it's either way. More. Find the value of a. So a is this constant here, but when I represent log p against t, is this value here, which is the y-intercept. Yeah, so I just need to find the y-intercept of my line of best fit. And again, I can use this value here, yeah, and find, so this value here, it will be this. Log to the base 10 of a will be that value here, because I'm representing log p, not y, yeah, so I can use this value here, or I can use the actual point, because I know when t is 0, log p is 188. So I could use that one just to be safe. In case I represent the line badly for whatever reason, I would use the value that I already have. You are going to get a slightly different value, and still you will get the marks. So it's, I promise it's either way. So a will be 10 to the power of 1.88, which is 7. Oh no, we don't need to do that, sorry, because this is already, we have the value here. P is 75. So and probably this will give us something with decimals, but we don't need it. So a is straight away, a is 75, because is this p here, yeah, with for the initial year. Next thing, this is the value of a, so we don't need units or anything. Using the model with k 0.02, predict the number of tons of annual global production in 2030. So this starts, so the t is the time passed from 1980. Yeah, so t is the number of years. So up to 2030, there will be 50 years. So t is 50. And the only thing I have to do is substitute in the model. So the model now says that the production is A, which was 75. If you found another A here, because if you use the line of best fit, you will get a slightly different number, 71, 72, something different. You use that value here, and that's okay. Then times 10 to the power of k, which they say use 0.02 times t. And I know t is 50 years, because 50 years passed. And if you do that with the calculator, you get, actually 50 times 0.02 is 1, 10 to the power of 1 is 10, times 75 is 750. We don't need even the calculator. And this is millions of tons. Yep. Next part, using the model again with k 0.02, predict the year in which p first exceeds 8,000. So now we are going to use again the same model, but we don't know t, we know p. So p must be greater than 8,000. So I'm going to find the first value of t that gives me 8,000. So I have this, and I need to solve the equation to find t. So first thing I'm going to do is to divide by 75 to have my 10 to the power of something alone. I don't get a decimal number, so I'm going to leave the fraction. It's going to be 10 to the power of 0.02t. And now I'm going to take logs, so I can rescue my t from the exponent. Yeah, so taking logs, I have log to the base 10 of 320 divided by 3 is going to be log to the base 10 of 10 to the power of something is going to be the something, yeah? So t is going to be this value here with the calculator divided by 0.02. And this is 101.4 something. So that means that from 1980 must pass 101.4 years. So if I add 1980, that means this happens in 2081.4. But I have to round to give the a whole year. So if I round down, because this is smaller than 5, I will get 2081, but there I still don't have the 8,000, so I will have to round up even if my number is closer to the one below. Yeah, so be careful with that, because that happens in 2082. So it's the first year I have more than 8,000 millions. Yeah? And then give a reason why it may be inappropriate to use the model to make predictions about future annual global production. One of the things that is happening is that we are well away or out of our range. Yeah, so always making predictions out of your range is extrapolation, which is not very accurate. But they are not asking really that. They are asking a reason why that could be inappropriate. So, for example, there could be we are talking in 60 years from now. So it could be that the production of plastic has decreased because there is more conscience or more worried about the planet, or the plastic has been even banned. So it could be less plastic produced, hopefully. So this can change with different regulations, less plastic produced. That could be something like that, and anything that makes a bit of sense here, you will get a mark. It's just one mark, and there is not a single answer that is correct. It's just they are asking you to see if you really understand the question. Yeah, and that's all with this question.